and welcome everyone to today's Synergist webinar, The Science of Separation, Impactors versus Cyclones. I'm Kay Bechtold, Managing Editor of The Synergist, the magazine of AIHA. I'd like to thank everyone for joining us today, and especially SKC for sponsoring this webinar. Today's speaker is Dusty Ott, CIH, Corporate Industrial Hygienist with SKC. Dusty has more than 14 years of experience across mining, oil and gas, aerospace, government, and manufacturing. He specializes in simplifying complex IH concepts and helping professionals improve sampling accuracy in the field. He's also passionate about bridging the gap between compliance and worker protection through practical, relatable education. And now I'll turn the presentation over to Dusty.
Thank you so much. Can you see my screen?
Not yet.
Not yet. Okay, let's try this one more time. How about now?
Perfect.
Perfect. Awesome. Well, it is great to be here today with everybody. And for the duration of the presentation, I'm going to hop off camera so you all can focus on the slides, and then I will come back again at the end for questions. So until then, I'll see you then. So today we are going to talk about the differences between cyclones and impactors, where they both make sense to use, where some of them might not be the best idea to use, some of the do's and don'ts, and some fun stuff along the way. So what we're trying to learn today is a little bit about size-selective samplers, what they are and how they actually work, the main differences between cyclones and impactors and how that can actually impact your sampling, no pun intended. We're going to go through some of the common mistakes that people tend to make when they're doing size-selective samplers. We're going to talk about how much sampling actually costs, which is kind of a fun subject. And ultimately, I want you all to gain some practical tips from today's presentation that you can take back to your site and be able to implement to better your industrial hygiene experience. So as far as how we're going to cover that today, we're going to talk a little bit about silica and why the accuracy matters of sampling, talk a little bit about size-selective sampling and what that means, what makes impactors a little bit different than a traditional cyclone. Like I said earlier, some of the do's and don'ts of sampling for silica. We're going to briefly touch on what can happen if you use the incorrect flow rate when you're talking about these size-selective samplers. And ultimately, we're going to talk about how much sampling costs and how that process works. So with that being said, this is probably not the first time that people on this call have heard about silica. And it's one of those things that is an invisible danger. So just like this little chunk of silica came from nowhere and it grew to this, awesome sized particle, it's not something that we can see with our naked eyes. The size of these particles are extremely small, and it makes it challenging as industrial hygiene professionals to be able to convey the true risk of these itty-bitty small particles to people that we work sometimes. I feel that if particles were this size flying through the air at us, that we would have a completely different story, and people would be much more likely to wear respirators when they should, water down the roads when they should, because this is something that we can visually see. We can see how sharp it is, we can see how dangerous it is, but because in the real world, it is on such a very, very small level, it is hard for most people to really grasp just the scale of size that we're talking about. And so as far as silica itself goes, it's not something that's going to hurt us right now. It's something that can hurt us 10, 20, 30 years down the road. Alternatively to that, I've been doing some international presentations, and there are some really interesting occurrences happening over in the Mideast and in India and China, where we are seeing a resurgence of silicosis in months versus years. And so for the purpose of this particular presentation and the traditional exposure that we get over here in the United States, this is something that typically takes 10, 20, 30 years to manifest. Now, these small particles are smaller than we can visually see. They are traveling deep down inside of our lungs, and they are bypassing a lot of the defense mechanisms that our body has in order to protect us from dust and other things getting into our lungs. And so this is where helping people understand the size and scale of what we're trying to do becomes a little bit challenging. So what is size selective sampling, and how can we help people understand it a little bit better? I like to kind of think of it as one of those change machines where you go to the grocery store, or you have something like this where you dump all of your change into, and you rotate that handle, and all the dimes go where the dimes go, the nickels go where the nickels go, and so on and so forth. And by selectively sorting our change, we know exactly what we are looking at. And so when we're talking about size selective sampling, we are selectively capturing the specific size range that we want. And when we're talking about silica, a respirable dust and silica, we are talking between 1 and 10 microns. So once we get our results back from the lab, when we look at our analysis, the numbers that we're seeing on that page are only in that range from 1 to 10 microns. And that is what we're comparing against occupational limits to see what, to see how we are comparing against regulatory, as well as some potential, some company limits that we have. And so I absolutely love this picture because it does a really good job of helping people understand these types of particles. Last week, before I gave a presentation, my daughter was down in my office, and she was asking me about this and what that meant. And she was asking, you know, how big certain things were. And it was funny when she finally realized that the hair was on the very top. And it was really fun to see her as a 10-year-old girl kind of have that aha moment of just how small things are that we breathe into our body. And so for this particular picture, I took that same chunky, gnarly picture of silica, and I put that in that respirable dust area of 1 to 10 microns. And that's what we're worried about. And what's really fun about this particular picture is we are talking about things as small as bacteria to sample. And so when people start understanding that, you know what, you can't see bacteria on your hands, therefore you can't see this dust in the air, that's where it's so much more important for us to help people understand what it is that we're dealing with. Now you'll see on the screen, there is the red circled part and a little dashed line that says the visibility limits of what the naked eye can see are between 10 and 40 microns. So literally, these things are invisible. We cannot see them in the air with our naked eye. And so when we talk about collection efficiency, this is something that I feel a lot of industrial hygienists don't quite have a handle on. And so I want to go over it again today just to make sure that we're all on the same page. Now, the collection efficiency, it refers to the percentage of particulates of a certain size that are being collected at a certain percentage. So if you look at this graph, we see that on the very far left, all the way to the very top, we have 100%. Now, that means, you know, 100% of things that are zero are being collected. As we look down this graph, we see that at 50%, we have a 4 micron size. So that means that of the particles that make its way through either the cyclone effect or the impactor, that 50% of the particles on that are going to be 4 microns. So if we go up the scale to 75%, we can see that about 3 microns or less are going to be collected on that filter. Now, alternatively, you go down to the other end, say something that's 8 microns. We're only going to have about 5 to 6% of the total particles on that filter collected that are, you know, 8 microns. And if you go all the way out to 10 microns, we have less than 1% of those particular particles being captured on our filter to send to the lab. And so it's important that as we go out and perform sampling, that whatever sampler we use conforms to the ISO 7708-1995 convention. That way we know that we are comparing apples to apples and not some other type of potentially some environmental cyclone that has a different cut point or the curve looks very, very different. So as we're talking about these collection efficiencies and how almost 100% of particles 1 micron are being collected, and almost less than 1% of particles that are 10 microns are being collected, that is it follows our body's natural ability to remove those particles. If you've ever been on a very dusty bike ride or on a Jeep ride, a four-wheeler, and you're following behind somebody that's kicking up a whole bunch of dust, as soon as you get back to your house, you take a shower, you blow your nose, you'll see that your tissue is full of a whole bunch of dirt. And that's our body's ability to remove those larger particles from the airstream very, very effectively. Now, if you think about as that air has that potential to travel down deep into our lungs, we have a number of different deposition sites along the way to help those larger particles, impact out of the airstream. So initially we have it as it comes into our nose and mouth. Right after that, we have the back of the throat, the bottom of the trachea, where the bronchi split. And then as the bronchi continues to split more and more and more into the bronchioles, there's just more and more sites for those little particles to impact on to get removed from the airstream. So as we know from previous discussions, that there are some particles that are so small that they just bypass all those little bronchioles and they end up impacting deep down inside of our lungs. And I thought it was kind of funny as I was originally making this presentation that it sounds like we are our own oiled impactor. We are doing a really good job of removing these large particles from the airstream. So the things that we are going to talk about specifically today to do that are cyclones, like we have on the left, or impactors that we have on the right. Now, each of them have a very different way of removing these particles from the airstream, which lends to them being really good for certain applications and not so good for other applications. So as we go through the presentation, hopefully we help you guys understand where it's going to be good to use cyclones, where it's going to be good to use impactors, where it's good to use both, and potentially even some scenarios where using either one is not going to be the best idea. So I really like this graphic. I think it does a really good job of illustrating exactly what a cyclone is doing inside. So as you can see, the yellow particles and the dark particles are coming into the inlet at the same time. As soon as it hits the other side of that cyclone, we see that those particles that are larger, that have more inertia, have impact to the side of the cyclone and are losing momentum, and they're slowly making their way down and dropping out the bottom of that cyclone. Or if you want to think of it as industrial hygiene stuff, it's dumping out into the grip pot. So alternatively, you look at the small gray particles as these are becoming, they are staying in the air, and they are being removed from the airstream by going up through that pipe. And when we're talking about sampling, that is traveling up through the cyclone and collecting on our 37 millimeter cassette that we send off to the lab. So as we look at this, it's important to understand just how important it is to clean your cyclones after each use. And we'll get a little bit more into that later. But I think this particular graphic does a really good job of showing what can happen if you potentially not cleaning the inside of your cyclones after each use, that we can have some buildup that's going to change the way that those particles interact inside of the cyclone. And therefore, it's going to change the way that dust is collected on the filter itself. So some factors influencing how the efficiency of these cyclones work is particle size distribution. Just like we looked earlier, is cyclones are not very good at collecting very, very small particles. Now, for what we're trying to do and collect those really small particles between 1 and 10 microns, that works for our benefit. It helps us to actually get rid of everything larger than 10 microns and collect just that swath of particle size that we actually want. So as you go down the list, the design parameters, what the inlet flow looks like, the velocity, the size, the radius, how long it is. There's so many different things that go into designing a cyclone. And the one that we're looking at right here is an industrial style cyclone that is used for a number of things in the industry, from removing fines to recycling paints to doing all sorts of other things that allow the cycloning motion to remove those small particles and out the top and collect the large particles out of the bottom. So on the very bottom, I have bolded that cyclone walls can be loaded with dust if not cleaned. That not only goes for our small little cyclones that we have in the lab to sample for, but that can also impact how well these larger cyclones are used in industry as well. So this is something that I've wanted to do for a long time. I love 3D printing. I love bringing some of these strange objects to trade shows to show people how things work. But this is our aluminum cyclone that I've sliced in half with the slicer to show you what the inside of that actually looks like. Now, a few things to note is this does not have a grip pot. I do not possess the 3D rendering skills to create a grip pot to put on that, but let's just pretend that the one's on there. And so you'll notice that the inlet, the dust that would travel into that inlet, you see the area where the vortex forms, that those larger particles impact the side of that cyclone, they spin out and then they drop out the bottom of the cyclone. So something to consider here is I have never seen the inside of a cyclone before I cut this 3D model in half. So I'm guessing the vast majority of people haven't seen the inside of a cyclone either. But I think it's really cool because it looks exactly like the industrial cyclones that we just looked at. That's not really a big surprise, but it's really interesting to see just how much surface area is on the inside. And it really shows just how important it is to clean your cyclones after each use to prevent, dust, especially if you're sampling in a wettish, high humidity environment, from those particles being impacted on the side of the cyclone and not being cleaned out could negatively affect how that vortex and cyclone are working. So again, I keep beating that horse, but cleaning your cyclones after every time you use them is very, very important. So as far as the other alternative to size-selective samplers, we are going to talk about impactors. This particular one is a parallel impactor. And what that means is that it allows, rather than having a multi-stage impactor that we'll look at here in a second, it allows 4 different size impactors to be all in parallel and be able to collect them in a much smaller package than what traditionally has been in the past. So this visual on the right is what a standard staged impactor looks like. You have stage 1, stage 2, 3, 4, 5, 6, depending on the size of the particles that you're trying to collect. Now what happens is dust travels into the inlet, and if it has too much inertia, meaning if the size is more than 10 microns, it doesn't have the ability to maintain and stay in the airstream. So it's going to impact on that impactor plate. Whereas these smaller particles that have less inertia, they're able to stay in that airstream and make its way down further on into the impactor. Now, ultimately, there'll be particles that are small enough in between that 1 and 10 micron size that are making its way past all of the plates and based on the collection efficiency being collected on that filter at the bottom, where we send those off to the lab to be analyzed. So when we're talking specifically about these little impactor plates, I alluded to earlier that we are our own oiled impactors. That's exactly what these are. These are little impactor plates that have little small amounts of oil that, as dust sticks to hits those plates, it sticks to them and prevents it from bouncing off and then being re-entrained back into the airstream. And this particular one that we're looking at, this would be potentially a reusable impactor. So after each time that you sample it, you would take the whole thing apart, you would clean off the impactor sites, and you would then re-oil them preparatory to using it again. So like I said earlier, this particular one that we're talking about is called a PPI, and this has 4 oiled impactors all in parallel with each other. And so as air travels in through the inlet, you'll notice that the holes do not line up with the next layer. And so as these particles travel in through the inlet, those that are too large are sticking directly to these little oiled impactors, and the ones that are small enough are able to make that 90-degree turn and stay entrained in the airflow, and then travel down and collect on your filter that you send off to the lab to be analyzed. And one thing about this particular one that we're looking at is this particular one is one that is reusable. And so you'll see that there's these screw holes that allows you to take this apart, remove these oiled impactors and replace them. There's others that are a single-use unit, that this top part is sonically welded to this particular part. So there's no cleaning. You just cap the top and send it to the lab to be analyzed. And that's the last you see of it. So as far as the PPIs that we're talking about today, they come in several different flow rates. Now, one thing that if you've done any chemical sampling or particulate sampling without a cyclone, and you're trying to get as much dust or as much volume through the tube or cassette as possible, all you're doing is you're increasing the flow rate to increase the volume through that. And the reason that you would do that is to get more particulate or more chemical onto your charcoal. And ultimately, you're trying to be able to make that more sensitive and to reduce your exposure, reduce the level of detection from the lab. So when we're talking specifically about cyclones or we're talking about PPIs, you can't simply just increase the flow rate, because you're going to change the cut point of that particular sampler. And so on the left, we have full shift sampling at 2 liters a minute. This is something that with normal amounts of dust, these PPIs, they can remove between 6 and 7 milligrams of dust from the air. And you can do that over the entirety of that shift. If you're trying to sample something that is either a very short task or something that you don't know, you're trying to figure out where the main exposure is coming throughout the day, being able to use something that's in the 4 liter a minute range or 8 liter a minute range allows you to still, without changing your collection efficiency on that curve, on the ISO curve, it allows you to collect either 2 times as much volume or 4 times as much volume in the same amount of time. And so I really see the 4 and the 8 liter a minute being used primarily for either task-based samples or samples that have a very low silica concentration in the air and that you've had a hard time in the past getting enough dust on the filter for the lab to even analyze. Now, I know there's some people in certain industries that not having enough dust on their filter is never a concern. Like, I think of myself coming from the mines. I don't think there was ever a sample I ever took that didn't have, at least or more than the limit of detection on those filters. But there are certain processes, certain jobs, certain things in our industry that have very low silica concentration, and we're still trying to figure out how much is in the air. And that's where those ones with higher flow rate really can make a big difference. So some advantages over a traditional cyclone is they have what we call it, a calibration adapter that you can hook directly to it. You're not having to use any type of calibration jar or method that can increase the amount of error into the system. One thing that's very nice about an impactor is there is no orientation bias, meaning that if you turn it upside down, you're not going to ruin your sample because there's no grip pot to empty onto your filter. All those little particles stick to the impactor. So whether it's right side up, left, right, up, down, it makes it very simple and easy to use, and make sure that particles aren't flying off of from the grip pot onto the actual filter itself. These particular ones are disposable, so there's no cleaning that's used. It's needed. You simply cap them and send them to the lab to be analyzed. They're smaller. They're easier to wear. You'll see some pictures later on with them mounted on somebody. You'll see the size of these compared to a Cyclone. From a regulatory compliance point of view, they are both included in the OSHA silica regulation as well as the new MSHA silica regulation. So we had a lot of questions when the MSHA rule first came out, if these particular samplers could be used. And I was very happy to see that MSHA took the time to read those questions and to include that in the final rule. So I'm not going to read the whole paragraph to you. You can see everything that's highlighted in yellow, specifically references the PPI. But what MSHA says in a nutshell is, as long as the sampler, whether it's a PPI, a Cyclone, whatever that might be, as long as that follows the ISO convention, you can use it for a regulatory sample. And the same thing goes with OSHA as well. So as far as sampling goes, like, what do you need to actually sample for silica? If this is something that's new to you, you need a constant flow pump. You need a way to verify your flow rate. Back in the day, we called these calibrators. Now we call them flow meters. You need some type of tubing to connect that sample to your pump as well as that flow meter. One thing that's very, very important is you need a pre-weighed 5-micron filter to use. Now, where this comes from is when you're talking specifically about respirable dust and silica, the respirable dust part of the analysis is a gravimetric analysis only. Now, if you don't know how much something weighed before you sampled, you're not going to know what the difference was once you send it in to get analyzed. So in order to make everybody's life simpler and easier, if you are ever doing respirable dust and silica sampling, always use a pre-weighed cassette. That way you can know the weight of the respirable dust on the filter, and then they do an XRD analysis to find out how much silica is on that particular filter, and then they're giving you a % silica of the dust based on the weight of the sample. So if you send in samples to get analyzed that do not have a pre-weight on them, they can't tell you how much the sample weighed. They can't tell you what percentage of silica it is. All they can tell you is how much silica is on the filter, and that is it. So again, please, please, please use pre-weighed cassettes for any respirable dust and silica type of sampling. Last two on the list are a notepad and a pen. Take good notes. Make sure that you are there and watching to be able to understand exactly what's going on. And if you can take a camera out into the field, I know that there's places that cameras are not allowed, and I totally understand that. But if you're able to take pictures or videos, they tell an amazing story that makes interpreting your results incredibly so much easier. So this is what that would look like from a visual point of view. You have your pump, you have a representative PPI, you have your cal adapter, you have a flow meter, and you have a couple different lengths of tubing so that you're able to make sure that the flow rate for this particular one, you'll notice right on the sticker, it says 2 liters a minute. And that's exactly what you want this particular PPI to be not calibrated to. You want the flow to be 2 liters a minute. So as far as proper placement goes, you'll notice the picture on the left. The gentleman has this tucked in right next to his hoodie. He has all of the tubing inside of his safety vest. So the only thing that's poking out is your PPI. This makes it very convenient for them, because one thing that I think we need to understand is that people don't love being sampled. And I think we all know that. And so if there's anything we can do to make their life a little bit easier, I think we owe that to them. And so for this particular one, I spent a couple extra minutes making sure that all of the tubing was in the appropriate spot, that when he sat down, it wasn't going to get kinked, that the pump was in a place where it wasn't going to be uncomfortable for him when he sat down. And ultimately, that placement of the PPI is exactly where we want it. There's been too many times where I've seen people put pumps and cyclones on people, and they have loose tubing. They have the pump just clipped on a belt, and as soon as they sit down, the pump falls off, it yanks off the cyclone, and then they're starting all over again because that cyclone ended up in the dirt. So just taking the couple extra minutes to make sure that human being is as comfortable as they can be, knowing that it's not going to be the funnest experience in their life to be sampled the entire shift, it goes a very, very long way. So as far as a couple improper placements, I think this is very obvious that we wouldn't want to have either a cyclone or a PPI clipped near their waist. That's not going to tell us any of the information that we want for a breathing zone sample. And furthermore, you'll notice that the tubing is left exposed. And what was fun when we were doing this, I was filming this gentleman getting in and out of a forklift. That hose caught right on his gear shift indicator and pulled it right off of his chest. And so, like I said before, just take the couple extra minutes, whether you have to tape it to the individual, run it under their vest, put it in a different spot on their body. Just take the time to make sure that it's going to be a successful sample for you and a very pleasant opportunity for them. So as far as some of the don'ts of silica sampling, that first one is doing a pre and post flow verification. This goes without saying. There's never a time that you are sampling that you should not have a pre and a post flow rate associated with that particular sample. Not taking any notes in the field, again, I think that's a great way to open yourself up to either misinterpretation of the results or not having a clue what happened throughout the day. Now, I know all of us are busy. It's hard to stay with every person throughout the entire shift, but making the best time to go and visit the different people throughout the shift, help them understand what's going on. From you as an industrial hygienist, being able to spend time with them, maybe even help them do their job, have a better idea of what exactly is lending to that particular exposure for the day. Like we showed earlier, not having the sampler in the breathing zone, that's kind of a simple one. And then lastly, on the bottom is not using an accredited lab for analysis. There are so many accredited labs across the country that this one, really, we shouldn't have any excuse for not using a lab that has the AIHA accreditation. So specifically, when we're talking about cyclones, if anyone's ever taken a cyclone sample, the main thing that you always hear is don't turn it upside down. And from somebody who's taken hundreds or maybe even thousands of cyclone samples, like the worst case scenario is end of shift. They are walking into the break room or the supervisor's office, whatever it might be. You can see them, the cyclone's in the right spot. Right before they take it off and give it to you, they grab it and they just turn everything upside down and hand it to you, or just drop it right on the desk. Like for me, like my heart drops down, like I'm like, oh no, like all day. You wore that all day and now you just turned it over at the very last minute. So it's very disheartening when that happens. I know that's happened to probably most of us on this call. As far as the inlet not facing the correct way, again, when you put it on somebody potentially with some loose clothing, make sure that as they're moving around, that cyclone is not going to have the opportunity to flip around backwards and sit against them. Or if they're wearing a coat at the beginning of shift and you do a really good job and you place it on them in the way that they should be, and then a half hour into their shift, they're too warm, they take off their coat, and then they decide to put your cyclone back in a place that's not going to work. Those are the opportunities and times we have to go back and sample again. Not cleaning after each use, I've beat that horse enough. We don't need to talk anymore about that. The last thing I'll say is that dust can collect on the inside of the cyclone and reduce the effectiveness of how well that cyclone is going to be able to create the vortex, and it'll change the size distribution of what is actually collected on the filter. The incorrect flow rate, we've already talked about this, but running your filter at your cyclone at too high or too low of a flow rate is going to move your cut point either to the left or to the right, and we'll talk about that here in a few minutes. Operating without a grip pot. This one is one of those ones that it's hard to I remember some of my interns I had when I was at the mines, and they came back and they didn't have any grip pots on the actual cyclone, and it was sad and kind of fun at the same time to explain to them that they had to go back and do the same sampling again the next day, because you can't sample without a grip pot because it's going to completely change and mess up your vortex. So again, please use a grip pot. And then this last one is something that I think is overlooked a lot of times, is that we don't use enough we don't use enough filter cassettes throughout the day if we know that we're going to have a lot of dust in the area, or that particular task is a very, very dusty task. If you think of the NIOSH method, we can only have 2 milligrams of dust on our filter to get analyzed. As soon as we start adding more than 2 milligrams, the validity of those results start going down, and or additional costs start to be involved. So if you know that you have a very dusty task, if you know that there's going to be a high dust exposure, be there to change out that filter cassette multiple times throughout the shift. So specifically from Impactors, the main two things are going to be similar to Cyclones, is that if you're using the incorrect flow rate, you're going to have the wrong cut point that are not going to be accurate, and it's not going to be able to be compared to the limits that you want. And the same thing that goes, we just barely talked about with the Cyclone, is that using multiple PPIs or impactors throughout the shift to make sure that you're not overloading the impactor, the small oiled impactors inside, to make sure that you have a valid sample. Because what can happen is once those little impactors have more than 6 or 7 milligrams of dust on them, they're not going to be effective at collecting those larger particles. So those larger particles will be able to bypass, bounce off of that impactor site, and then make their way down into the filter to get sent off to the lab to get analyzed. And then you'll get a little note on the side of your result to say larger than measurable particles were found on the filter. So we've already talked about this a little bit with both of them, but just to reiterate this one more time, you can have less than 2 milligrams of dust on that particular filter for the NIOSH analysis. So high dust environments, this is going to be no surprise for people, mines, construction, foundries, or other areas where there's lots of dust in the air. We've already kind of briefed over and talked about how much dust the impactors can take out. And then again, how dust can build up on the inside of the cyclones and reduce your cut point. And there was one time I remember when I was cleaning out a cyclone after a shift, I noticed that there was a chunk of dirt that was plugging probably 2/3 of the inlet of my cyclone. That is a very good reason why that particular sample would not be valid. And that's, again, allows you another opportunity to go and resample that particular task. So again, we're going to have some consequences of that from voided samples. Please, like I said, in those high dust environments, make sure and change your filters, your cassettes, or your PPIs multiple times throughout your shift to make sure that you're going to have the best results that you possibly can. Now, from the takeaways for this, if you understand your exposures, going into them with multiple cassettes you can change out throughout your shift is a huge benefit for you. I know there were certain times when we were trying to figure out exactly where the main dust exposures were coming from for like something on the underground mines. I would take 5, 6, 7 different cassettes underground, and I would change them every half hour, every hour, depending on how long we were trying to figure out what was actually going on for that particular employee. And again, it gives you the granularity to figure out, based on a task sample, how much you're being exposed to, but also make sure that your results can be reliable and that you can go back and you can stand behind them at the end of the day. So as far as flow rates and their impact on cut points, it is inversely related. And what I mean by that is if you use something that, let's say that we have a 2 liter a minute PPI. If you use something that is if you decide to run at a 3 liter a minute volume versus a 2 liter a minute volume, what you're going to do is you're going to reduce the cut point. So all of the particles that end up on your filter are going to end up being skewed to the left. Now, alternatively, if you use a lower flow rate, you're going to increase your cut point, and you're going to end up having larger particles ending up on your filter in a lot higher percentage than you would otherwise. Now, what that looks like visually is this. So if we look at our yellow mark right here, where the green mark is what we run the aluminum cyclone at. If we decided to run that particular cyclone at 2 liters a minute, you see that our cut point has moved from 4 microns up to say 5.5 microns. And then on the other hand, if you decide to run that same cyclone at 4 liters a minute, you've moved that cut point from 4 microns all the way down to say 2.5 microns. So we've said it before that size selective samplers, especially cyclones and PPIs, are very, very sensitive to flow rate. And so being able to make sure that they're operated at the correct flow rate will make all the difference in the world. So just quickly from a practical point of view, if you think of yourself in a nice big truck around a fast curve, it's going to be a lot harder for these larger particles to stay in the airstream versus something that's very small and maneuverable, like an F1 car. So after we sample, we're taking a post flow rate, we're calculating our volume, and we're filling out our chain of custody to send to the lab to get analyzed. The samples are then received by the lab. Like I said before, they're going to be weighed in a very sophisticated, a very fancy, expensive scale, so they know exactly how much dust was increased on the filter throughout the sampling. After the filter is weighed, it is going to be digested in tetrahydrofuran. And what this allows it then to do is you run that through a funnel and concentrate the dust and the silica onto a silver membrane filter. And from that filter is then hit with an X-ray beam, and then what is reflecting off of that silver membrane filter is going to be categorized because each of the different types of silica has its own, air quotes, signature, so they know exactly how much silica is within that particular sample. So from an actual analytical cost, it's very inexpensive to weigh something. For example, if you use a NIOSH 0600 to just measure purely respirable dust, it's only $24. As we start making our way down to add different polymorphs, whether you need quartz, cristobalite, and tridymite. Say that 10 times fast. And it continues to add some price. Now, there are some labs that even if you have more than 2 milligrams of dust on your filter, they will split those filters in half and analyze them separately. And this is just type of, depending on how much dust is on the filter, will determine how much additional cost it is for them to still be able to analyze that, because you can no longer analyze it as a single sample. So that's where it goes back to using multiple cassettes or multiple PPIs to help alleviate some of this additional cost that can happen when you're actually sampling. So some additional costs to consider is resampling due to invalidated results. That can be from cyclones tipping upside down, from them not being in the breathing zone, wrong flow rates. I think the list is pretty extensive for that. Follow-up samples, depending on if you're above or below the PEL, if you need to do follow-up samples to check the validity of your controls, that all goes into the equation of resampling. So other ones to consider are regulatory costs for penalties. And what I thought was really nice about the MSHA rule is that they did a very good job of estimating how much each sample costs based on how large of a site and how many people are on that site. And where they're getting that from, they're considering lost time from the supervisor, lost time from the employee being sampled, your time as an industrial hygienist, in addition to the actual analytical cost. And they're estimating that every sample that we take in the field for a site between 21 and 500 people is about $380. Now, take that as with a grain of salt, knowing that some areas or some facilities that cost will be more, and some facilities that cost will be less. But the takeaway is industrial hygiene sampling is very expensive, not just from an analytical point of view, but also your time, as well as the supervisor's time that you work with, as well as the individual's time that you're sampling, and everything that goes into that day. So everything that we can do to help alleviate resampling is a huge cost savings on our part. So to close things up is some practical considerations. And I showed this picture to my wife. She thought I was pretty funny, but sometimes you get done sampling and you feel just like Mr. Rambo getting completely beat up throughout the entire shift. And so as far as PPIs, it meets all of the ISO criteria. It's referenced by OSHA and MSHA in their final rules. They're smaller, a little bit easier to use. There's not really any maintenance associated with them if you use the disposable ones, because they're just sent to the lab. They're compatible. The same lab methods are used whether you use a cyclone or an impactor. They're a little bit smaller, less intrusive, like we talked about, and overall they're a little bit easier to deploy and to place on the person, so they're not in their way. As far as cyclones go, it's cheaper to sample with a cyclone because each 37 millimeter cassette is about $5, so they're very inexpensive. They've been used for decades. They've referenced in older regulatory methods. They're very durable and well established across the industrial hygiene field as a whole, not just in the US, but around the world. You can have some increased voids and resamples due to tipping or not using the grit pot, like we talked about. Additionally, they are compatible with existing lab methods and pumps, and it's something that most industrial hygienists are already familiar with. They're widely taught in colleges around the country and around the world. So with that being said, what questions can I help answer today?
Great, thank you, Dusty. Looks like we have about 10 minutes for questions. Just a reminder, if you'd like to ask a question, please send it through the chat window. I've got a bunch queued up for you here, so hopefully we can
Very cool.
Get to all these.
I'll do my best.
Great. First question is, what size/weight is the pump worn for 8 liters per minute?
So there are a couple of pumps on the market. The one that comes to mind would be the Leland Legacy pump from a standpoint, they're about that big. So about not quite twice as big as a traditional pump would be.
Great. Next question is, what is the best way to clean the aluminum cyclone?
So you take that grip pot off, you run water down through the top part, through the inlet, through the bottom. You can use a little pipe cleaner to get inside to get all of the potential dust and gunk from the inside of the cyclone. But I think what's really important to note here is when we're talking about, I happen to have one right here, is you see all these little areas that can collect dust or grime once they've been cleaned. So being able to store, to let it dry like this, to make sure that all of those little particles are making their way down and not being collected around where that vortex is made is a really big point to make. And whether that's with one of our cyclones or really any cyclone on the market, being able to make sure that you're not drying chunks of dirt up on top, it's going to change the way that that vortex is formed.
Okay, thanks. Next question is, can a pre-weighed filter be used in a PPI to analyze respirable dust along with silica?
Yep, absolutely. Every time, every silica sample I've ever taken, whether it's a 37 millimeter cassette or if you're using a PPI, it's analyzed the exact same way. And so pre-weighed PVC for Cyclone, pre-weighed PVC for PPI, you're getting the NIOSH 0600 for the weight, and then you're getting 7500 for the XRD for silica.
Okay. Is there a lab where I can get the 4 or 8 liter per minute PPI?
Yes, for sure. There's plenty of labs have those either on hand or can order them directly through SKC.
Okay, great. Next person has a comment and a question. Obviously, larger particle movement is dictated by their inertia, while smaller particles will more easily follow airflow, but there may still be some of the desired particle fraction that land on the oiled impactor or impactors. How is that taken into account with these PPIs?
So you look at the sampling curve, and if we're gonna talk specifically about the PPI, the 2 liter a minute PPI that has a 4 micron cut point. That means that 50% of the particles are being impacted and 50% of the particles are making their way down onto the filter. Just like it would be with a cyclone, that's how the ISO curve is designed, and that's how it works. And so even when we look at something, if you look at that curve again at around 2.5 microns and you have a 75% collection efficiency, that's 75% of those particles are making their way down to the collection filter to get analyzed, and 25% are being impacted onto the impactors. And the same thing would be with a cyclone. It follows that same exact science and collection efficiency, and that's all designed into it.
Thank you. Next question is, SKC published a document about adapters for the PPI to prevent overloading. Can you speak to this technology?
I sure can. So those adapters are specifically designed for when we're talking about projectile motion, I guess you'd call it. And so if you've ever bought a pizza from Pizza Hut or Little Caesars, they usually have these little things that sit in the very center of the box to keep the box from sticking to the cheese. And so what these small little adapters do is that they slide over the face of the PPI and they sit off, I don't know, 3/4 of an inch or so. So it still allows particles that would naturally be, I guess, ingested by the PPI to still do that. But if you're talking about things that are being shot at it, whether from a grinder, sandblasting, if you're using it for cutting and things are being shot and flung into the PPI, it's artificially changing how that particular thing works because it's not working on natural airflow, it's working on projectile motion. So having this in front of the inlets is going to prevent those large, fast-moving particles from just shooting directly into the intake holes of that PPI.
Great, thank you. Next question is, if we have a large quantity of sampling to be done, how can we manage to constantly change PPI?
The same way that you do with a cyclone. I know that resources, both money-wise and people-wise, are tight these days. They always have been. And it just depends on what you're trying to do. If you're really trying to figure out exactly what part of this process is lending to the majority of the exposure, taking a day or two to nail down what that looks like will make a big difference versus continually just doing the same thing again and again and again, which is just full shift sampling, which tells you a single number. There's no peaks or valleys. It's a time-weighted average. And so being able to take a little extra time, maybe even pair it up with a real-time monitor so you can have some actual eyes on what that exposure might look like throughout the entire day would be a huge asset. And so if there was one answer to that question is I'd say use some real-time monitoring at the same time you're sampling with either a PPI or a cyclone to give yourself some more granularity so you can see peaks and valleys and figure out where that highest exposures are coming throughout the day.
Thank you. Next question is there interference when sampling during wet conditions?
Oh yeah, for sure. There's interference, whether you're a cyclone or a PPI or any other type of sampling for that matter. Like if we're talking specifically about, say, tile cutters, that you're cutting tile with a nice cooled and lubricated water that's shooting right at you, into your face, into the PPI, into the cyclone, that's going to drastically skew what those results are. Even if there's no airborne silica in the air, you have a ton of entrained silica particles inside of that water that has now been shot into your cyclone or into your PPI. And as your pump continues to dry out the water, you're left with a little slurry mix. And we've seen this of having 100 to 1,000 times the exposure limit on these filters for these very, very wet methods. So yeah, absolutely. Water will definitely mess with your samples.
Thank you. Next question is, can either or both of these methods, cyclone/impactor, be used to measure exposure to carbon nanotubes?
If they're trying to sample respirable nanotubes, I don't see why not. So the main difference between a total sample is it's just a closed face 37 millimeter cassette. You have something like an IOM to sample inhalable fraction. And you have something like a cyclone or a PPI to measure the respirable fraction. So it depends on what they're trying to measure and if there's exposure limits associated with respirable nanotubes. I don't know for sure if there is or not, but there's nothing to prevent them from sampling either one with a PPI or a cyclone.
Thank you. I think we have time to sneak in one more question. This one's related a bit to the one before last. Someone's asking, does cigarette smoke interfere also?
I don't know for sure. I can't imagine it would. I know when we would sample diesel particulate matter underground, we would always make a note that if they were smokers or not, because it could change the concentration of organic carbon on that filter. But for cyclones or PPIs, speaking of dust, I can't see how that would make any difference at all.
Thank you. Unfortunately, that's all the time we have for today. We will be sharing all questions from today's event with SKC, so if we didn't get to your question, please know that we will pass it along. My thanks to Dusty Ott for his presentation, to SKC for sponsoring today's webinar, and to all of our participants. Please check aij.webvent.tv for announcements of upcoming Synergist webinars. Hope everyone has a great day.